Welcome back to Teacher Neth Explains channel. Don't forget to subscribe, share, like, tap the notifications bell, and leave a comment. Given a table of values, check first whether there is no repeated x value. Check also if there is no repeated y value. If there is none, then it is a table of values of a one-to-one function. And to represent the table of values of its inverse, simply interchange x and y values.
For example, given the following table of values, represent its inverse through a table of values also. Check first, no x value is repeated. Also, no y value is repeated. Then, it is a one-to-one function. And the table of values of its inverse function is where we just interchange the x and the y values. That is, the x values of the given function becomes the y values of the inverse, and the y values of the given function becomes the x values of its inverse function.
On the other hand, given a graph, you may check if it is a graph of a one-to-one function, as we have learned if it passed both the vertical and horizontal line tests. Then, reflect the graph about the line y equals x because the original function and its inverse function are symmetric to each other about the line y equals x. That is how to draw the graph of its inverse.
For example, draw the graph of the inverse of f of x equals 3x. So in a Cartesian plane, first, we will sketch the graph of the given function f of x equals 3x. Let us consider some of its points. How do we plot these points? This point says that if x is negative 2, y is negative 6. That is, if you substitute negative 2 to x, this will become 3 times negative 2, which is negative 6. That will be the value of y. So if x is negative 2, y is negative 6. So from the x-axis, locate negative 2. From the y-axis, locate negative 6. They will meet at this point. So that is how we plot the other points. And when we join them by a straight line, because this graph or this equation consists of an infinite number of points, they will form this line. Now, let us do the vertical and horizontal line tests. Notice that wherever we draw a vertical line, it will intersect the graph at exactly 1 point. So it passed the vertical line test. And wherever we draw a horizontal line, it will intersect the graph also at exactly 1 point. So it does not only pass the vertical line test, but also the horizontal line test. So it's a one-to-one function. We may draw the graph of its inverse by reflecting it about the line x equals y or y equals x. It says, whatever x is, that is also the value of y. That is, if x is negative 3, then y is negative 3. If x is 100, then y is also 100. Or if x is 0, then y is also 0. If we plot some of its points and join them by a line, this is the graph of x equals y, or the line of symmetry between the given function and the graph of its inverse. Now, how do we sketch the graph of the inverse of this f of x equals 3x? Suppose this is a paper. You fold the paper along the line of symmetry, or x equals y. Then trace this line, the orange line, the given line, on the other side of the paper. And you'll form another line. This is the graph of the inverse of f of x equals 3x. They are symmetric about the line y equals x.
So you have just learned how to represent an inverse function through a table of values and through a graph. Until next time!